In this video, we are going to work on problem 3.4.6 from the textbook. Let f be a continuous function on the interval AB, and let x1, x2, xn be n numbers in the interval AB. And then we have to prove that there is some c in the interval AB such that f of c is the average of f of x1, f of x2, and f of xn. Now, let me analyze this problem. Here is the graph of a continuous function on the interval AB. Okay. Now, for simplicity, we consider the case where n is equal to 2. Now, x1 and x2 are two numbers in the interval AB. This is f of x1 and this is f of x2. The number gamma is the average of f of x1 and f of x2. Gamma is equal to f of x1 plus f of x2 over 2. And we have to prove that there exists a number c in the interval AB such that f of c is equal to gamma. This figure suggests us to use the intermediate value theorem. Let me recall the following version of the intermediate value theorem. Let f be a function defined on the interval AB, and we assume that f is a continuous function. Here, alpha is the smallest function value in this interval, and beta is the largest function value in this interval. Over here, this is alpha, and this is beta. Okay. Then for any gamma, such that gamma is greater than or equal to alpha and less than or equal to beta, there exists some c in the interval AB such that f of c is equal to gamma. Okay, so this is the theorem that we are going to solve the problem. Define the following numbers. Alpha is the smallest function value in the interval AB. And beta is the largest function value in this interval. Now, by the extreme value theorem, because f is a continuous function, it has an absolute maximum and an absolute minimum in the interval AB. Therefore, alpha and beta are two real numbers. Okay, because x1, x2, and xn are in the interval AB, we can see that f of xi is always greater than or equal to alpha and less than or equal to beta for all I from 1 to n. Okay. Then we see the following. The average of f of x1, f of xn, the average of these numbers is always less than or equal to beta plus so on plus beta n times over n. Okay, because again each f of xi is less than or equal to beta, and as you can see here, this is n times beta over n, so it is exactly beta. Okay, and at the same time, because each f of xi is greater than or equal to alpha, this sum is greater than or equal to alpha plus so on plus alpha, and again there are n times in this sum. Okay, over n, and again this is exactly alpha. Okay, so this number gamma is greater than or equal to alpha and less than or equal to beta, where alpha is the smallest function value in the interval AB and beta is the largest function value in the interval AB. So by the interval value theorem, there is some C in the interval AB such that f of C is equal to gamma, that is the average of f of x1, f of xn. So the proof is complete.